All right, we're going to run our first hello world. You're probably going to want to grab this file and either download it to your desktop or upload it to your virtual machine. This is at this path in the course files. So this is just a simple hello. It has a workflow with a single task that writes a greeting, both echoes it and writes it to standard out. And importantly, miniwdl requires that tasks run in a container. So you can see in line 16, this container is going to be pulled from Docker Hub, and it's just an Ubuntu container. And this is a real common pattern in bioinformatics, so that you have your configuration encapsulated in the container description, which is a Docker file, basically. So going over to a Jupyter Lab, we now want to work with this. Now, what I've done is I've just uploaded this by clicking the plus here and then just filling this in as a new text file and making sure it was a WDL file. Now I've run this a couple of times, and each time you get an output directory, which again, I like this interface for teaching and learning because you get a terminal, but you also get this visual tree. So it's just kind of handy. So in the terminal here, the first thing that we're going to do is we're going to use miniwdl check, because we want to check the syntax of our hello WDL file, and we're going to specify no shell check. Miniwdl check works with external tools. Shell check, if you're not familiar, is a checker of bugs in shell scripts. So just showing you an example here, I've got the beginning of a loop, and you can see there's an error over here. I would need to put a do in here, and then I'd have to do something to get rid of that error. So in any case, miniwdl integrates with this because it's a common pattern that you will have shell scripts encapsulated inside of tasks. But we're not going to really explore that. I'm just going to tell you that that's there. Right now we just have a simple call. So inside of here, we're going to check and make sure that our file's okay. So you can see that it not only verifies, but it also summarizes. And this is a really useful capability because lots of WDL files out there are really long. And it gives you the name, the workflow, the call, which is which tasks are called, and then the fact that the task is defined. Very, very handy. Now, if you had a mistake in your file, so I'm going to go here and force an error. I'm going to call a task that is not defined because they have a different name. So I'm going to go ahead and save this. And now I'm going to rerun this. And it says, oh, oops, you don't have that task. So again, a common situation in bioinformatics is you're finding somebody's WDL and you want to understand it quickly. So the check capability inside of miniwdl allows you not only to parse, but also does an outline. And we'll see this with longer files as we work through this course, but it's something that I think is super handy. So I wanted to call it out right now. So this particular file is really simple in that it doesn't operate on any data. So we'll shortly get to a WDL workflow that takes a file to process as input and then creates a file as output. Now this one does create a file as output, but it's basically just taking the string hello world. It's not processing or anything. So there's no variables here in terms of an input file or an output file. It's just writing to the standard out location. Again, we need to walk before we run, so this just gets us started. So speaking of running, we can just run this and we don't have to specify any input parameters. So all we have to say is miniwdl run. And notice it runs really quickly. If you caught that, we have now another output folder here. So let's first look at the screen, then we're going to look at the output folder. So you can see that the green information is telling us how the WDL file is being run by the miniwdl runner environment. And it's creating a job that is writing the greeting. And again, just reading through this, you can see where the output is being written. And it's working with Docker Swarm, which is a coordinator of Docker container images. In this case, we have one worker, maximum of 4 CPUs. Here's the amount of memory shown as well. And again, this becomes really, really important when you move to production because you got huge amounts of data going through your pipeline. And so you need to set up your compute cluster correctly to process that data. And then here we're ending, and you can see we're done. Here we have our output. Now in terms of our output, you can see that this is 638. So if we look here, this is 638, and I ran this a few other times. So now I can jump into here, and let's take a look at what kind of output is produced. So the first thing that is interesting is the out. And we go into the output greeting and standard out, hello world. That's where we find basically what we're looking for inside of standard out. And that is a sort of a typical pattern. Now what else do we have in here? Well, we have call write greeting. We go inside of there, we have another out. And again, we have hello world. Now why is that? Well, we have a task and we have a workflow. So we have output from the task and output from the workflow. So that actually does make sense that we have the two outputs here, because that's the way that we've specified it. Now if we go back up, and of course if we had multiple tasks, we would have a call folder for each of those. We can go at the top workflow level and we can look at the whittle. And again, this is just going to be the same whittle that we just used, basically. And in the inputs, we don't have any because we have no parameters. The output is the location where the output is written. Now notice the syntax, hello world, which is the name of the workflow, write greeting, which is the name of the task, and output greeting, which is the name of the variable. Again, if you go here, you can see output greeting on 13, 7, write greeting, 3, hello world. So it's a hierarchical naming. Rerun is just a handy utility. So there is a caching capability in miniwdl that we'll cover later on, but this is useful that you can see that we have this rerun capability. And then our log is going to look familiar. Basically, it's the same information that we have right here. So that's kind of a tour of what is output for each run. So again, just to re-emphasize that point, if I say miniwdl run hello, and you watch closely, you now have a fourth execution directory here.